Well, good morning and welcome to the last panel of the day on real-time analytics. We heard from Keith that industrial companies, industrial automation manufacturing, generate 2 exabytes of data. An exabyte is 1 billion gigabytes. That's a lot of data. Well, all of this data today is locked up in industrial assets, whether it's manufacturing plants or field-based assets. I mean, just imagine if you were to get this 2 exabytes of data out of these assets and you want to connect all of this data with IT data, are we going to need a lot of fat pipes? What are we going to do and how will we process this data? Today, analytics is a buzzword, and so is big data. So the panel we have, I'm really happy, delighted with the panel we have, because this panel is not going to be doing a fireside chat on theoretical aspects of analytics or big data. We're going to give some real examples of what are we doing today with big data, how are we leveraging analytics to provide value, and that's the kind of discussion we're going to have with the panel today. So we're going to dig right in, and what I'm going to try and do is probe the panel on what are some of the real applications of analytics. Okay, what are the killer apps for analytics? How do we handle big data? Is that really going to be an issue for us? Do we need very, very fat pipes? I know that's going to make our friends at Cisco really happy, but are we really dealing with big data today? Are we moving lots of data? We'll talk about that. What's the impact on business models? Like Rick Schneider is here from FANUC. Is he still going to be selling robots, or will he be selling uptime in the future? So what's the impact on business models? And finally, we'll also talk a little bit about what does it mean for people in the plants? As we put in more analytics, as we deal with more data, as we connect the enterprise, and we get more value from all this connectivity, what's the impact on people? So these are some of the areas that I'm going to be probing the panel in, and we'll leave some time for you to ask questions as well. So keep your questions jotted down. I'll definitely come back to you, and we'll save about 10 minutes for Q&A. So let me dive right in. I'll start with Blake. I'll ask Blake, what is Rockwell's definition of analytics, and what kind of business value is Rockwell deriving from analytics today?
Sure. Thanks, Sujit. Well, simply, analytics is repeatable insight from operations to drive better business decisions. And it's about contextualizing data in terms of the actual business problem that's being looked at. It's analyzing the data flows, and sometimes these data flows are very intuitive, other times they're not so intuitive. And then it's taking action. And in the real world, sometimes those actions are as simple as helping an operator pinpoint the cause of a failure quicker and decreasing mean time to repair. Other times they're predicting failures so that you can prevent the bad thing from happening. It's about rolling up production data across multiple facilities. It's about optimizing processes in real time. But in the end, today, the killer app for those analytics in industrial operations is around reducing unplanned downtime. That drives a rate of return faster than anything else today.
So Blake, I recall an important statistic that states that unplanned downtime costs 15 times more than scheduled downtime. So Francisco, let me turn over to you. In your plant, do you see unplanned downtime as an issue, and what value are you planning to derive from analytics?
Okay, well, in Maynilad Water, we're basically a water distribution company. We're in this journey. I think somebody in the earlier panel mentioned that this is a journey. So one of the things that it's a reality for us today is really this convergence of IT and OT. In terms of applications that we've developed or are in the process, for example, we now have hydraulic modeling, which is a core system in the water industry, which allows us to pick up pressures, flows along all our network and be able to simulate how, for example, an expansion in one area would affect the delivery of water in that area. So being able to harness all this information. Other examples are in one of our water treatment plants, we're able to capture operational data and actually email alarms to the plant manager, operations head before the actual occurrence of a failure or a problem in operations occur. We also are upgrading, but we have operationally our leak management system. And this is a good example wherein we use data from many different sources, IT and OT. We get, again, field data, but we also get, for example, asset information from our GIS, which is basically a map of all our assets distributed all over, and combine that with billing information in order to detect where leaks are most probably present in our network so that we can pinpoint them. This actually is of great help because since most of our assets are underground, it's actually very hard to dig only to find out that the leak is somewhere else. And then we also are using, for example, field data as well to optimize our pressure regulating valves. Pressure regulating valves actually determine the amount of pressure in an area that is delivered depending on the time of day. And it's a complex problem because you want to deliver enough pressure to the farthest point in our network, right? But not too much pressure so that you have leaks. So that cannot be done, for example, with a traditional PID. So we actually collect the data, and one of our hydraulic engineers came up with his own algorithm in order to optimize all these PRVs. And last, if I may, right now we are upgrading, we're installing many more sensors in many of our critical facilities, such as pumps, major motors, to be able to detect more than the traditional signals. So we can now measure temperature, vibration, current, and be able to do, this is the idea, again, this is a journey, be able to do condition-based maintenance so that even before the asset has a problem, it already rings an alarm by analyzing all this information so that the maintenance crew is sent in. So what all of this actually means for us as a water company is water is highly regulated, so we only have so much upside in terms of revenue, right? So it's really a play on cost and efficiencies. We have to decrease our costs to be able to be profitable as a private company. So that's the name of the game for us.
So Francisco, I just wanted to clarify something you said. You said you're collecting a lot of real-time data, like pressure data. You're also analyzing this data in real time. And some of this data is being combined with the data in your IT system, like metering data. So does that mean you're implementing analytics in a scalable fashion?
Well, I'm the head of IT, and I also handle automation and instrumentation. So really our role is to provide these tools to the end users, right? It's really the end users that know the process to be able to come up with optimization. And yes, the data may be real time, but the analysis, that takes more thinking. That's seldom real time. So the idea is to be able to provide them all the information or all the data that they need and let them do their own analysis on the available information.
Very good. So Rick, I'm going to turn over to you now. I know FANUC has a major initiative on zero downtime, and you're going to be featuring that on the show floor at Automation Fair. Can you talk a little bit about zero downtime, and is it delivering value today?
Interesting, as I hear a lot of people they're talking about the journey for the Internet of Things, a connected enterprise. For us, I characterize the journey as a little bit more of like a slingshot being launched. We had a problem with one of our major customers. We were having unplanned downtime. A certain component would fail without warning. It was located in the machine that was hard to replace. It was in the middle of a production line. And from the time it went down to get that machine back up and running could be 4 to 6 hours. 46 hours, there wasn't redundancy. We were taking entire automotive plants down, and to the point where we're actually losing saleable vehicles to their competition. So we had that major challenge. We couldn't find a root cause. We had a lot of our best people working on it. And with the Rockwell partnership, you invited us to be on the steering committee for manufacturing for the Internet of Things. We went to the 2-day event and started hearing about some of the potentials for Internet of Things, collecting data, doing analytics, and we said, could we use this to help us solve this problem? So we immediately went back and started putting together a test site. We took what we saw the highest risk machines for this type of a failure, and we started pulling the data out and doing analytics on the data, and we looked for certain symptoms. We had another failure. We didn't catch it. And the first reaction is this approach didn't work. But once we had heard in the seminars, collect big data. And we had our engineers go through and analyze that data, and they found some symptoms that happened 2 to 3 weeks before that failure. And then we changed our algorithms to look for those symptoms. Since we found those symptoms, and again, this downtime for a customer could be $2.5 million per downtime incident. We started tracking those symptoms and have been 100% at catching those downtimes, and again, 2 to 3 weeks before the failure. We're able to go into the customer, we're able to say we need to make a change in this component, but also it helped us analyze what the root cause was, what the symptoms were, helped us analyze the problem. So back in terms of value, we didn't start with a business case and say, here's our goal, here's what the value we want to generate. We had a major problem to solve, which we were at the edge. If our best customer, much more downtime, it was really a major impact to them and us. So first of all, from a value standpoint, we saw this saved our customer probably in excess of $30 million in terms of the 25 instances we caught in advance. From a reputation standpoint, if we didn't catch that, a lot of times the downtime is not caused by the component failure, but it's the application of the product. But also what we found is in each machine we have a black box recorder, and a technician would go in and connect in the black box and pull the data out. We were pulling that data out every 90 seconds and looking at it. We found that it's a gold mine of information in terms of not only can we predict a failure, we can prevent a failure by asking our customers to change a process, predictive analytics, improve quality in a process. So all of that has happened in less than a year. And production model in less than 6 months, we're over 2,500 machines. So for us, it's been a very fast ramp up, and the investment cost has been relatively low. The return on investment has just been amazing to us.
I like the slingshot journey example. So it looks like that's what you're on. So let me move on to Wayne. And I know 3M has been looking at information management, analytics, getting value from all the data in your plants. So can you talk a little bit about what 3M is thinking about in terms of implementing analytics, information management, and deriving value from all the data?
Sure. So it's not really a new journey for 3M. We've been collecting data for many, many years. And when we first started collecting data in our process equipments, as instruments got cheap enough that it made sense for us to add the data collection capability, we found ourselves chasing a lot of blips in the curve that weren't necessarily important and weren't really driving us towards the root cause of the problems. So we started putting in place more, I'll say, BP charting, graphics, and getting that in front of our operators. And we still found that even though we were getting better at being able to take the data now and turning it into information that we could act upon, you still, without some better model-based understanding of your process, you're still chasing a lot of ghosts that were out there, whether that be instruments that were not giving us correct data, data wasn't cleansed correctly, whatever, any of those kinds of applications. So we're now moving much more towards a more model-based approach where we try to understand what our process should deliver based on the inputs that are available, the raw materials that we're using, the data sets that are available to us, and try to predict what should the outcome look like. And if it doesn't look like it should, go back and run more analysis on it and say, okay, where is that problem coming from? Do we have motors that are failing, bearings that are failing, whatever? That's been a relatively recent event for us. But we're still trying to do that real time on the production floor because that's where you want to try and stop the rejects from happening as well as happening on the production floor. Then you take that same data and you push it up to our own, in our case, we're pushing it to our own servers and running big data analysis on it to say, okay, are there things that are maybe a little bit more difficult to make those connections, that we need to go back and basically update our models that we're running on the production floor in order to get better accuracy on what are defects or changes in our data that we need to respond to.
Perfect. So, Matt, your company makes instrumentation, and by Keith's definition of smart instrumentation or smart machines, you have microprocessors embedded in your instrumentation, and they're connected to a network. So how do you plan to leverage all the data that you collect in your instrumentation? Are you planning to run analytics? And talk a little bit about the business value that you see that you can derive from collecting data in the instrument itself.
You know, our journey started with Anderson Hauser about also 20 years ago, like to the first panel, because we had many manufacturing sites all over the world, and we wanted to produce the same quality, same leverage all around the world. So we needed below the ERP system an MES level and a data pool where all the data get in. And out of this, since almost 15 years, we collect all the data which happens in manufacturing. Calibration, configuration, all the bits and components are inside. And today we have, I think, more than 30 million data, products, serial number tags in our database, where we have the whole life cycle in. So from the birth of the device to the life cycle at our customers, we can collect those data and always bring it back to the same serial number, so we know always the status, what the product looks like. What is the advantage or what is the value for the customer is quite clear. When in the middle of the night one of the device fails, you do not want to reconfigure the device in the middle of the night where you don't have the competence there. So you just plug and play. You rip it out, put a new one in, download the data without a lot of knowledge, and immediately the unit is running. Another advantage is 70% of all services we do out in the field, or our customers do out in the field, are reactive. They happen something, and then people have to go out in the field to do something. Today, I would say 95% of all service calls you can make predictive, because the data is there. And the last element is we developed then with the microprocessor and with the technology what we call the heartbeat technology. The unit is intelligent itself, and it tells you when something has happened based on the circumstances around him. So this allows then the customer to really reduce the downtime, have less service calls out in the field, and it can manage the data generator out in the field over the life cycle in a seamless fashion.
Very good. So it looks like there's confirmation of the point that Blake made about reducing downtime as a potential killer app for analytics. We also heard from Francisco that he's using it for optimizing water distribution in his water plant. So let me now move on to the next topic, which is let's probe a little bit as to what does it take to implement analytics and how do we handle big data. So let me start again with Blake. So Blake, what are your thoughts on how do you implement analytics? Is all that 2 exabytes of data, does it all have to go into the cloud and we process it in the cloud?
I think a really key concept is that we need to provide a scalable solution that puts the right information in front of the right people who understand the process at the right time. And we found that many times the most effective analytics are performed close to the original source of the data, so at the device or at the controller. You also see infrastructure being put in place at the so-called edge of a manufacturing process, so still within the user's firewall. And then for the truly big sets of data, or for very highly distributed assets, then there is the opportunity to use a secure cloud. But it's a scalable approach, and it can grow with an individual user's needs as they take that journey.
Okay. Francisco, would you agree with that?
Well, our personal experience was that, talking about big data, is we actually don't need big data. And although there's a lot of data coming in, and most of it being field data, it's quite repetitive, right? So you can actually compress it, right, very efficiently. So in our case, we didn't see the need to put up a special infrastructure just to do that. I think the bigger challenge for us really is again, talking about process, in order to do a good analysis of the information, you need someone who is knowledgeable of the process itself. And that domain expertise is very hard to come by. And it usually means the guy really operating there or close to the function. You know? So that for us is more of the challenge.
Okay. So when you seem to be agreeing with Francisco's point about domain expertise needed
Yeah, I think
for analytics.
data's data, right? Certainly there's analysis that can be run on that, but you need a ton of information, ton of data to run analysis on a process that has other inputs going on, that unless you're integrated with the process and very knowledgeable about how that process works, it's very difficult to draw those conclusions unless you collect an enormous amount of data. So I think Francisco and I have talked earlier, but having process knowledge, intimate process knowledge, with a small amount of data, you can move the world, right? I mean, you can correct a lot of problems that would otherwise go on for a long period of time at the source of the data. So there's always those opportunities that gets missed, that the models aren't accurate, that there's a part of the process interactions that maybe weren't understood before. So pushing that data up on a regular basis and running a more full-scale analysis on, quote, big data certainly can generate maybe new thoughts about what that process model should look like or how it might interact. But getting it down to the user level and having analysis that you can run quickly and get reactions fast out in the field and correct the problem is to me, key to analytics.
So what I'm hearing you say is...
Let me add also, I guess one of the questions is, what data do you store? And our experience is that store everything. I mean, as long as it's there, might as well store it, because you find out that initially this may seem sufficient, but then as you go into the process and look into it, you may actually need to put in more. Right. So if you can put in as much information or as much data as you get available in the sensors, then
yeah. You know. So what I'm hearing is, I heard two things. One is there's a lot of repetitive data, as you said, Francisco. And a lot of the data can be pre-processed where it's generated, and that kind of chokes the data down into what you need to move maybe into the IT servers or into the cloud. The second point that I think you guys made is understanding the process, knowing how the process works, and the domain knowledge of the process is going to be absolutely key to getting value from analytics. Just running analytics, you know, is not a big deal, but you need to derive value from the analytics. So let me turn over to Rick. So Rick, I know you're moving data from robots into the cloud. Is that big data?
From our perspective, it is. In the past, we would have, again, the black box and a robot controller. We have a technician go in and connect into it. But we see all three levels. We see edge computing is something that we really want to enhance the performance of the machine itself. Working with Rockwell within the plant, which we call more of the cloud computing. But in some cases, we really felt we need to bring that data out and more of what we call big data to be able to analyze it. One example on the problem I was talking about we're trying to solve, we actually put additional memory devices to collect data at the machine. We go back a week later and this had been unplugged. The plant really didn't want us to know exactly what was going on in that cell. Now, every 90 seconds, we're bringing that data out. If the machine is pulled offline, we know right away. The implementation we have is, and I heard a lot of talk about security, that's not our expertise. And I think the Internet of Things, and it really requires partnership. So IT department really did not want us bringing that data out. So the manufacturing group said, this is great, we've got to make it happen immediately. So we went with Cisco to the IT department, and they said, we'll put in a data collector at the plant. We'll send it out securely. We'll put it on the Cisco cloud. FANUC will log into the cloud. And that type of infrastructure was acceptable from a security standpoint, but we still had to move in stages. We had to move plant by plant, country by country, and now we're starting to open up data centers with Cisco in Europe and Asia to get their confidence. But we see that the IT and OT groups are saying, we've got to win. Mm-hmm. We're both benefiting here, and the implementation is secure, but it's a slow process to build that confidence that you're not going to do harm and actually have a positive implementation.
So Matt, in your instrumentation, you're collecting a lot of data. Are you shipping all this data up for analytics, or are you going to pre-process the data? How should we think about how the future is going to evolve with analytics at the sensor level, at the instrumentation level?
I mean, there are several subjects. One thing, I think data does not replace the cognitive capability of a human being. This is what we talk about. The person has to understand what the process is. However, data can help you to recognize pattern, right, what happens, and you can predict pattern, what will happen. And you have several layers. You have one set of data which is inside the device, and then you can make a pattern recognition, what happens inside the device to give information outside. However, you also can say the data of the device and the data of the environment the device is in brings together a cognitive decision, which normally a human being does. And you can help the human being by analyzing those data in a certain way to come faster to that decision. In the case you have in the waterworks, the data can help, and the pattern can help, and the algorithm can help, that the hydraulic engineer comes much faster to a decision to support that point. What is key? First, security and safety. We have heard that becomes together. Shell said this is for me one and the same. I think I would absolutely agree to that, because if one of the field devices fails, you are blind in a process, so it cannot fail. The second point is you have to have communication means from the device who creates the data to the point of the ERP system or the outside world. And therefore, you have to have communication means which is transparent and not proprietary. And now we have the dilemma, we do not want proprietary systems, but we want secure and safe systems. And there we have to find the right balance. And I believe at the end of the day, the IT technology will take over the communication path from the device all the way to the ERP system. And we will see the Ethernet IP, and we will see the Wi-Fi technology in the device, standardized like we use in a mobile phone, however with secure and safe measures around it.
Very good.
Yep.
Let me now turn over and talk about, we heard that the technology evolution has created a tipping point for the connected enterprise. So now that a lot of our customers are realizing the connected enterprise and realizing some of the benefits from the connected enterprise, let's now talk about whether it's going to change business models for automation vendors like Fanuc and like E&H. So Rick, I'm going to ask you about how you see your business model evolving in the future. If you were to look in the crystal ball, will you be selling robots as you sell robots today 5 years from now?
You know, the most exciting part for us is it really has completely changed our go-to-business model. At least on the front end, it'll be the same, where we meet with customers and systems integrators, explain what our products will do, and how to best apply them and the advantage it has them for the manufacturing process. And that will stay the same, but after we have sold that robot to the end customer, the integrator, we really have very low insight in terms of how it's being applied, and robots have a lot of flexibility to be used in a variety of applications. In the past, usually the first time we would get any feedback on how that customer was using that robot is when we got a call, we had some downtime, or we had a problem. And our goal was we wanted to be at the customer's plant with a technician within 6 hours at the maximum. And we would set up offices and service engineers to respond. Now that we're getting feedback from that robot every 90 seconds, we're able to see what the application is, how it's being utilized, and provide a whole range of services to that customer. So we're going from reactive to that phone call to proactive in terms of saying, the way you're running it, you're going to be doing damage to the machine. The way you're running it, you actually can reduce the energy consumption of the machine, and by modifying the program, you can enhance the cycle time. But then expanding out, because now that we've got the approach to get the data out up to the cloud, we can start looking at their process equipment in terms of how it's being utilized and implemented, and then go farther out to we're looking at paint shops. Not only downtime and maximizing uptime, reducing energy, but paint quality. So we can look at monitoring humidity, the paint mix. And so we see bringing a community of companies together to where we can actually improve the performance and the efficiency all of that was invisible to us in the past. We really didn't have access to that information. Bringing that in, running analytics, working with partners, seeing what's possible, it has dramatically increased our ability to improve customer satisfaction. We can be so much more predictive and supportive to them, and also in terms of generating revenue, because now there's a lot of services we could offer proactively that we didn't have any visibility to. Needs that they have going in and doing an audit machine by machine, but bringing that data in, having analytics run to see how it's being utilized, tremendous value that we can offer in terms of after services and follow-up and customer satisfaction. So that's probably the most exciting part to us. It's completely changed our go-to-market strategy after that machine has been sold.
Wow. So that is really transformational. Not only are you selling the robot, but you're selling uptime. You're also monitoring and optimizing the process. You have the opportunity to do that for the customer.
Exactly.
Matt, do you see a similar view from your perspective, from E&H's perspective? How do you see the business models evolving around instrumentation?
I mean, we have always been the census of any process, and this will continue to be the same case. We want to make field devices. But what changes is, of course, in the past, we needed to define, okay, what field devices the customer need, and how do we connect this field device to his architecture? Mm-hmm. Now we have heard that the architecture is not an IT and OT. It merged together, and at the end of the day, we will have one IT architecture at the customer side. But what will change is from the people for process automation, we will be able to provide much more intelligence and improvements out of the data our devices create and the knowledge we have around the applications, which is our core business. And out of this, we can sell, of course, more value around the field device by services, by helping the customer analyze where the problems are, where the problems might be in the future. And therefore, we will have much more products also about the field intelligence and the process improvements capabilities.
Very good. Yeah. So I only have 2 more questions to ask our panel, then I'll open it up for you to ask questions. The next question I want to ask our panel is, what are some of the challenges? We heard that safety and security are a couple of the challenges that you have to deal with when you implement analytics. So what are some of the other challenges? That's one question I'm going to ask. And the other question I'm going to ask them is, what's the impact on talent? When we put in more analytics, more data processing, more information management, what's the impact on talent in industrial automation? Let me start with Blake. So Blake, can you talk about the challenges that you see for implementing analytics?
Well, we talked about security, and that's always the first and the last question when we talk about moving data around, particularly across the firewall. Clean data, it's kind of mundane, but having consistent data that's clean, that can be able to be put into the proper context is a really important challenge. And anybody who's gone through a big enterprise-wide transformation knows that you also hit a speed bump with cleaning your data. The presentation of the data in the right way to the right people is another challenge because you can't just put everything onto a single screen that is right for the operations people as well as the engineering group. And I think the final one, we touched on it before, but as we knit together, as we combined the technology and the domain expertise, it really creates, from a vendor standpoint, the whole as-a-service portfolio, and those don't fit cleanly into established organization charts. So often we find a need to reshape our organizations to be able to bring together a combination of products with the expertise sold as one deliverable.
Very good. Francisco, any thoughts on some of the challenges? Because you've done IT-OT convergence.
Yeah. So, well, I guess let me start with that. So this happened about 2 years ago, and it really happened. I was initially in charge of IT. 2 years ago, there was really a gray area in terms of who was in charge of automation and instrumentation, and my boss, the president, volunteered me for the job. So here I am, right?
Voluntold.
But that's a challenge because in a situation or in a company where you actually have 2 people responsible for it, nobody wants to give up control, right? So I don't really see how that can happen. It's very difficult, right? So that was a good thing for us, right? The second challenge, of course, is security, but I won't talk about that because there was a lot of discussion on that topic. But the third, which is very important for us today, is governance, data governance, right? That means data ownership, who owns what data, because a lot of the data is coming in from many sources, right? So who owns the data? How do you keep it clean? And at the same time, who owns the outputs? Not only the inputs, but when you have an analysis that cuts across many different data, which were before in silos, who's in charge of that, right? So we came up with a data governance model. And the first thing that we did actually is no data governance. We just try and put in as much data as possible, just to prove that something useful can come out, right? By not restricting people outright. And after that, then we phased in the data governance. But that's really work in progress. I mean, just last night I received an email requesting access to certain data and the change in profiles in terms of who's supposed to be in charge of that. So it's a learning process.
Okay, very good. Rick, any challenges that you encountered? I mean, you did mention that you had to win over IT to implement zero downtime. Other than winning over IT, any other challenges in the implementation of zero downtime?
I think the clear challenge is it's not something that we could do as one company. So by partnering with Rockwell, it really helped us on the OT side and convincing manufacturing, engineering that this is the way to go. On the IT side, we would not have any chance to convince the IT department by Cisco talking to the IT department saying, here's a secure, we don't want to be in a security business, we don't want to be responsible for the data and transferring it. So you have to have that partnership. I think that the next challenge is the vision is clear, is the connected enterprise is the way that companies are going to increase productivity, as Mr. Nashpa showed in his presentation. It's very clear. Companies don't want 5, 6, 7, 8 ways of getting data out of their plant and making them secure. So I think it's having a common approach that we can go forward with companies, because we're not one company, we're talking to hundreds and thousands of companies. So a open approach where multiple companies can connect up, one that IT feels comfortable with. And so trying to build individually a closed approach is not going to work. If it's working with partners, key partners in the industry, and coming up with something with customers they feel secure from the IT standpoint, and the more partners you can connect onto that open infrastructure, I think it's a win for everybody. So that's the key, is putting that partnership together, the right type of database, the cloud storage, the edge computing, what fits in, fog computing, getting that moving forward. But the killer apps are there that are compelling enough. We're seeing it's getting customers motivated to address those challenges.
Very good. So you're reinforcing what Keith said this morning, which is you need a high-performance architecture that's open. You need to work with partners to really get all the pieces together for the connected enterprise.
Absolutely. This presentation was right on.
So Wayne, your thoughts on challenges as you're embarking on this journey, or the slingshot journey, as Rick calls it?
Well, Jim Weitzel and I spend a lot of time talking about best practices sharing, and the 3M is just entering the SAP conversion from our multiple ERP systems that we've got around the world, multiple MES layers around the world. So understanding how do you, first of all, want to make sure your manufacturing operations can run even when they're not connected if something happens to your cable. Understanding how do you summarize the data to make an effective decision-making process at the ERP level and push that information back down. Understand how to summarize information about the life of your equipment. In some cases, oftentimes we don't have it working, it's not working kind of situation. We have a situation where it's working, but the oven isn't performing exactly what we want it to. And we might have to break into our production schedule and say, all right, we're going to run a product that maybe doesn't require that zone of the oven. Or maybe we run a product at some lower line speeds or some other change that we can make to the process based on our understanding of the model and say, okay, we're going to run it that way. But now we got to inform the ERP system that says, okay, we're not going to make the production rates that we thought. We maybe need to transfer raw materials to another location because we will have to take this line down to take repairs, and we'll do that at some point in the future. So understanding how do you move that information from shop floor to the MES layer to the ERP and back in a logical fashion that you don't destroy your data set in the process.
Very good. So Matt, from your perspective, what are some of the challenges for leveraging analytics and actions from that?
Well, I think the key is that the connection to the data through the whole architecture is based on open standards the IT technology is using and not proprietary systems. That's, for me, key. Otherwise, you never have access to the data in the way you should have it. The second point is the safety and security part has to be embedded, as the colleague from Shell said, in the engineering part. We have engineers who run our factories, process engineers, and these people have to breathe what security and IT technology means. As more we standardize this, as more we use it in the conventional life, as easier it will be to adapt. And of course, the third part is for me, we have to educate young people and we have to excite young people for manufacturing. This is cool, this is IT. And therefore, I think this will change automatically with the next generation of engineers. For them, it's standard.
That's a good segue into my last question, and I'm going to direct this at Francisco and Wayne. What's the impact on talent? Do you see us going and recruiting data scientists that live on the plant floor? How does it impact talent, all this talk about analytics and big data?
Well, that's a good question and hard to answer. I guess it would depend in the context. I mean, I've actually attended a chief data officer conference just talking about data quality and coming up with the role of the CDO. We don't have a CDO in our company. It's really distributed. And as Wayne said, it's the people that know the process. So that works at different speeds. Some take it up fast, some take it up slower, right? But I think that's the model that we're going to stick to. But then in terms of talent, what this actually requires is really more analytical skills, down at the line level. And then I guess that's the challenge, because I think it's challenging already getting enough engineers, right? Now you have an additional requirement, right? So as Wayne mentioned as well, the more we can model and pre-package, the better, because then you don't depend so much on an individual. But of course, coming up with a model, you need the people to do that.
So Wayne, any closing thoughts on talent?
I see it, years ago when I first started at 3M Company, 30 years ago, it's amazing. But, we used to hire controls engineers, we used to hire designers and mechanical engineers to design the motors and gearboxes and drive chains and whatnot. And we found over the years that model doesn't work anymore, right? The controls part of it and the mechanical design are very intertwined. And so we started moving towards more mechatronics types engineers, right, that could handle both. So I see that shift just continuing now with the more the analytics or the physics behind the processes. And so I don't know that I see it being, a wholesale, we got to, cleave off a part of the company and bring somebody else in new, because there's a lot of knowledge of the process that has to go with that no matter what. But there certainly will be a shift to more the physics and the analytics behind what's going on the production floor. Similar to what we did before with separation from controls and mechanical, combining those together now, combining that again with the analytics is just a sort of a natural thing that's going to happen.
Very good. So let me now open it up to Q&A from all of you. We have a couple of minutes left, so if you have any questions, please step up to the microphone.
Everyone, we've heard a lot about the trend that's going on among automation suppliers about how you're not just selling the product anymore, you're also selling the potential to do services with the collection of the data. But how is it on the other end to who you're selling it to? I mean, because this is still really new in the industry to be able to do this. Are the actual end users receptive to this? Because it's changing their business model about how they buy these products. I'd like to hear
Sure,
about
I'll make a quick comment on that. You know, as we talk about the IT-OT convergence, it's not just about the technology. It also extends to buying preferences as well. And so buying technology as a service is something that has been common in the IT world for a long time. And we're seeing it start to come into the non-carpeted part of the enterprise as well. And so infrastructure as a service, obviously software as a service, subscription models rather than one-time perpetual licenses. So we are starting to see that, and to create a portfolio to match those needs where a user has decided that that is the way that they want to purchase, I think is important.
I think, you know, the point is if those data can help to overcome the customer's business challenges, then he's willing to help out, he's willing to accept the services. Downtime, failure rates, quality improvements, etc. Just connectivity and data, he's not willing to pay for. Very simple.
Yeah.
It has to be a value for him.
We have another question over there.
Good morning. Nusrat Jamali from Gulf Today, United Arab Emirates. In the first round of discussion by the panel here, one point came up, that is productive failures. So I request if you can further elaborate that point, that what exactly those failures are. And secondly, are those failures because of wrong implementation of analytics, or because of any external attack, or because of improper planning?
So what are some examples of failures, and what is the cause of those failures? Is it wrong implementation? Is it some other causes of the failures? That was a question.
We say in a lot of cases it's how the product's being applied. You know, we often don't see what the end application is. So in many cases, it's not a component failure, but it's the application of the equipment is either causing a failure or reducing the life of the machine. And so coming in and giving consultation on those changes. And even on the previous question, we see a lot of times manufacturing runs a little bit like a freeway. Everyone's driving over the speed limit, and then there's an accident, and then it stops. And what we see the Internet of Things really smoothing that out and moving at more of a consistent pace, and not misapplying the products which have been invisible in the past. So we think that visibility for us, we look at a little bit of looking over the shoulder of our customers, which wasn't possible in the past. That visibility really lets us improve their capabilities of applying our machines properly. And so we say in the majority of the cases, it's letting them apply the product to its maximum capabilities, as opposed to really finding something in the products that's not proper. But also, in terms of designing the next machine, if we really understand how the customers are utilizing our machines, manufacturing, it helps us to design a better product. So it even helps us up front in terms of machine design.
Okay, we can take one last question.
Hello. One thing that came to mind in listening to today's and yesterday's presentations at PSUG is it's IT and OT convergence, or is it IT absorbs OT and all becomes part of the same group? And I'm seeing a trend line there with some of the people that have presented already.
Yeah, just, you know, hopefully the message that you need the process experts came through loud and clear. All of the analytics engines in the world, and there's a whole bunch, won't do you good if you don't know where to look. And so having those process experts is going to be indispensable if we're going to take full advantage of those analytic tools.
And that will probably never be IT, correct? I mean,
Wayne, you're saying.
I disagree.
Francisco, would you agree with
I
that?
think it's a team. They're going to become a team instead of departments.
Yeah. I mean, I see IT really taking the lead on making sure that you get the data where you want it, when you need it, and understanding how you move that data securely, how you move it effectively, how do you package the information so that you can push it when the pipe is not flowing full speed. But correct, I agree with what was said. I mean, we need to understand the process part of that, and how do you take the information that the data provides you, or the analytics that data provides you, and how do you implement that and make a change out on the production floor that really is meaningful. Yeah. And that part probably won't be either sitting at a desk someplace outside the factory. It could be within the factory walls.
So closing thoughts, CIO, from the
well,
CIO?
if I may add, I mean, the real challenge is OT familiar with the process, right? Which IT usually is not. However, the challenge for OT is to understand business process, not factory process. That's the hard. So either way, you have a challenge, right? So it just has to be, I guess,
so collaboratively solved.
Collaboration and to forcibly be able to understand both worlds. Because IT is not just about connectivity and megabytes. That's the simple stuff.
Yep.
The hard part is understanding, like you're saying, how to implement an ERP so that your production planning can run smoothly, which is business process.
I think the IT will stop there where the hands have to get dirty. And that's in the process.
So with that thought, we're out of time, so I just want to close. I want to sincerely thank our panelists. I hope they gave you some insights that you didn't have before. So I really want to say thank you to our great panelists. Appreciate your time here this morning. Before we have one more talk before we wrap up today. I'm going to turn it over to John McDermott, who's our Senior Vice President for Global Sales. He's going to give you a quick preview of what you will see at Automation Fair tomorrow. So with that, thank you, everybody.